Good morning. Today is November 4th, 2017, and this is the John Chappell Natural Philosophy Society Science Chat. We're an open forum for people to discuss any alternative theories for science. And you can find us at naturalphilosophy.org. And we also have forums, and we're also active on Facebook. Feel free to give us a like and join our society for the advancement of science. And so today, this is our third week with Mohan Al-Habib and his 3 videos that he has. Well, I wanted to ask you, I mean, your videos are done very well. So do you do all your own videos? And like, who does your voiceovers?
No, voiceover, I get it done from a professional.
Oh, you have a professional to do that work for you?
Yeah. In the sense, there's a studio. You get a lot of people here who will do this voiceover. They charge a nominal amount, but it gives a very good effect because my voice is very bad, really.
Yeah, because I was looking at that, it's like, wow, those animations that you came up with, you know, I'm a computer guy and I know about computer animation. I know that none of that is trivial. It takes actually a lot of work to come up with those kind of animations.
No, the animation is done by a different person. He is also professional. He does it for me, and I get the audio done in another studio.
Yep. So that's I just wanted to congratulate you on those, because I make my own videos, and I just got to kind of put together whatever I can do myself, since I can't really afford anybody. I wouldn't even know who to talk to. But your professional's like, wow. I mean, those videos look great, you know.
And they are quite cheap here. They are not very costly. I can afford it.
Really, maybe we should get together with you so that if I need to make my next video,
yeah,
I can hire your guys to do it.
Yeah. Okay, I'll give you the link next time.
Uh-huh. Okay. So we've talked about your 2 videos. So the first one we discussed was whether the moon actually rotates. The second video was about basically whether gravity really exists, or I don't know, or at least basically can't be canceled by free fall. And your third video is on the ether. So why don't you give us some background on that, and then we can show part of the video that you had.
Okay, this the ether, right from the time of Aristotle, that means more than 1,000, 2,000 years back, right from that time, most eminent scientists, philosophers, academicians, professors, and eminent persons believed that space is not empty, it is filled with an ethereal substance known as ether, and all the celestial bodies floated in this ether. So that is why they are able to orbit and all that. This is one aspect of ether. As per the famous philosopher Rene Descartes, ordinary matter is a condensate of this ether, because our body is, it is not only electrons, protons, neutrons that we have. What he's, of course, at that time this was not known, but the belief was that ordinary matter, that is our bodies and all that we see around us, is nothing but a condensation of this ether. So that was as per Rene Descartes. Even Sir Isaac Newton felt that ether formed a part of matter. So slowly, once this Michelson and Morley experiment failed to detect the ether, from then on, this Einstein came up with this theory of relativity, and ultimately they said ether is not necessary. Space, time, and this and that, everything came up. And from maybe 100, 120 years, ether has been almost banned. Like, people are scared to talk about it. So what I want to prove here is another thing I wanted to tell. So earlier the belief was that Earth moved through this ether similar to how a submarine moves in water or a spacecraft moves in space. But actually, the Earth is not at all in contact with ether. According to me, the ether exists from above the Karman line. So this is what I want to try to explain and do in this discussion.
Okay. So I did notice that your video, we're kind of only seeing the top of your head there, so we might want to adjust your camera so we can.
Yeah, now? Can you see?
There you go. All right.
Yeah.
Otherwise, well, actually, see, now you're cutting off the top of your head. Just a little bit more there, so.
Yeah, okay. Yeah, no?
Still cutting off the top of your head. Okay, right there is good. Okay.
Yeah.
All right. So I don't want to feel like you're submarining below your camera there. But let's go ahead and watch some of your video then.
Yeah.
About this Kármán line, which is this line which is like 62 miles up, which is defined as the edge of space. So
the beginning of
the beginning of space. Okay, so this is your video here.
Accepted that outer space above 100-kilometer altitude from the although Einstein did not specify physical properties of space, mankind successfully accessed outer space only after his demise in 1955. The following are the numerous physical properties possessed by the supposedly empty vacuum of outer space existing. Astronauts and all unattached objects present inside spacecrafts, which are above the Kármán line, experience weightlessness due to what NASA terms as microgravity. Another reason behind weightlessness is explained as follows. Since spacecrafts orbit the Earth at high velocity, around 27,000 kilometers an hour, they are in constant free fall around the Earth. This explanation is absolutely false because objects inside sounding rockets, which don't orbit Earth but instead go vertically upwards into space and then fall down, also magically begin to experience weightlessness as the rocket crosses. All the engines are switched off. As all irrespective of mass which goes towards the present down the Kármán line, quickly assume a spherical shape. 3. During reentry, spacecrafts are subjected to those strange and inexplicable phenomena. During reentry, spacecraft weighing hundreds of tons bounce back into space at exactly 120 kilometers altitude from the Earth's surface in their angle of attack always less than 40 degrees. If airways maintain at 40 degrees, they will manage to descend, but will be subject to extreme heating. Strangely, spacecrafts do not heat up between 180 kilometers altitude. The actual heating due to wave occurs below 80 kilometer altitude. Since 99.99997% of Earth's atmospheric air is present below the Kármán line, and all of the remaining 0.00003% spreads out in the thousands of kilometers of space above this line, until phenomena occurring at 120 kilometer altitude have no logical scientific explanation. On Earth's surface, even a bomb will not bounce up until it hits a hard surface, and heating will not occur until friction is present. Hence, the above two phenomena clearly indicate that there is some invisible substance other than air present between 100 and 120 kilometer altitude, which gives rise to surface tension as well as friction when spacecrafts with high velocity try to penetrate it. 4. Orbits are possible only above the Kármán line. All region of space between 90 and 100 kilometers is also spacecrafts which possess the required orbital velocity will not attain a stable orbit, or otherwise occur only above the common line. 5. Orbit decay. All those spacecrafts that possess the required orbital speed will attain an orbit above the common line. They are subject to severe orbit decay, which is highest just above it and decreases gradually as the altitude increases. To overcome orbit decay and maintain the spacecraft at the required altitude, booster rockets fitted on the spacecraft are fired as and when required. Currently, this phenomenon is attributed to Earth's atmospheric drag, which is highly questionable as the space above the common line is an absolute vacuum. 6. Bending of Starlight passing close to huge celestial bodies. When Starlight travels close to huge celestial bodies, for example our Sun, it bends due to which the position of the star when observed from the Earth will appear to be slightly shifted. Isaac Newton was the first person to predict that starlight would bend around huge celestial bodies due to the great intensity present around them. Currently, the only proven reason behind the bending of light is refraction. 7. Gravity assist. The speed of spacecraft can be made to increase or decrease when they enter and exit the gravitational fields of a celestial body by manipulating their entry and exit directions. 8. Gravitational fields. People trying to walk around a solid spherical object resting on the Earth's surface measuring about 1 or 2 kilometers in diameter will end up falling into the ground. However, the same object would be in deep space, it would be surrounded by its own gravitational field and they could walk all around it without falling into space. For example, the Rosetta mission orbited and landed on the comet 67B Spherical, which has a diameter of about 4 kilometers. 9. Space has no ups, no downs. From the Earth's surface and within its gravitational field, elsewhere, space is always in the upward direction, and down is always towards the center of Earth. It is within the sun's gravitational field that it tends to fall towards it, but does not fall as it is in motion. However, if our Earth or any other celestial body were positioned motionless in an area of deep space with gravity is negligible, for example, exactly between our Sun and the nearest star, and from their perspective, all directions would be the same, that is, upwards. This is because they are now caught on the gravity well of any other celestial body. Hence, in such an instant, irrespective of mass, they would remain suspended, float in the same position. By observing the various physical phenomena which occur only above the common line, we don't need to be a rocket scientist to understand that outer space is not only filled with an invisible medium having elastic properties, but the density of this medium is highest just above the common line and decreases gradually with altitude increase. This is exactly similar to how the Earth's atmospheric air exists. Since none of these phenomena occur below the common line, we can safely presume that this space medium is absent from our inner atmosphere that is below the common line. This presumption leads us to the following interesting as well as important question. Why does this medium exist only from above the common line and not below it? There can be only one logical explanation for this, which is that this medium and the matter that constitutes Earth, including the atmospheric air, mutually repel one another. Scientific discoveries have led to the establishment of one irrefutable fact, which is that the laws of
All right, we're going to pause there for a moment.
Yeah.
All right, so what do people think of that video? You guys can hear me? A moment, yeah. So was that a good part of the video to show, Mahonau?
Yeah.
All right. So what do people think of that? I mean, what you're proposing is fairly radical, that there is this different substance that actually appears above the Kármán line.
And that is ether actually. I have not taken that word. I have just called it as space medium, but it is ether. It's a physical entity. It is
All right. So,
It is not a gas, but it is. You can say sponge-like material. Sponge. It can. It's elastic in nature, and it repels. According to me, it repels with our Earth. That is why it is above. I mean, it is starting from above 100 kilometers altitude. If you go to the moon's Kármán line is around 20-25 kilometers in height. That's all.
well, I found it
So,
curious. So I asked you the question of, if you were to take a sounding rocket and bring yourself a jar, and
yeah,
so you went above the Kármán line, you would open up the jar,
yeah,
let this ether material flow into the jar, basically
correct.
capturing some, close it up, and then bring it down to the surface.
Yeah,
And so what did you say you would find when you brought this stuff
yeah.
down to the surface?
This is a very, very good question, and I will answer this. Now, say we have three jars. One jar, we remove all the air and make it into a vacuum. Okay? One more jar, we leave, ordinary air at atmospheric pressure is inside it. The other jar is the one we have brought down from space. That is the one that go above the Kármán line and bring it down. Now, if you inject a little bit of water in the vacuumed jar, the water will start boiling. Am I right?
Yeah, well, I think it would fall down to the bottom and it would start boiling, yes.
Yeah, falling in, then it will start boiling. In the atmospheric, in the jar which has only air, the water will fall down and stay at the bottom. There will be no boiling, nothing. But according to me, if you inject water in the third, which contains the space medium, water will neither boil nor will it go down. It will take the shape of a sphere. The same thing what happens in space. That is my presumption. Because in space it is happening means that if we have brought down that material onto our Earth, the water will not go down. It will form a sphere.
So it would be floating in the middle of your container of ether?
That I'm not sure. That I cannot guess. It might, but 100% it will form a sphere. It might float or it might rest on the base. But 100% I'm sure it will form a sphere, with indicating that uh, the area of space above the Kármán line is different. It is filled with some substance which is giving rise to these phenomena.
Well, how do you think gravity, because if it forms a sphere, I was thinking that, well, it does so because there are no other real forces acting upon it that can distort the sphere. One of most of those would be gravity.
Yeah, see,
So
this is only a presumption. 100% only when we conduct the experiment we will come to know. Otherwise, it is not possible without conducting experiment. It is only a presumption. I feel that way.
So you would think that if gravity was still there, would it drag the sphere to the bottom of the container?
No, it might stay at the bottom. It might float. That I am not able to guess. But I will tell you one small example. See, now we are standing on the surface of the earth. Do you know that by going just another 5-6 feet, we can lose 90% of our weight? Okay.
No, I don't. I don't.
Now you jump into a swimming pool, what happens?
Well, you jump into the swimming pool. Yes, you
Your
become
weight,
buoyant.
yeah, buoyant, and your weight, if you are weighing with the weighing scale, it will be only about 10% of the actual weight. NASA conducts experiment, not experiment. They
Actually,
train their
I think even
astronauts.
less than that.
No, NASA trains their astronauts who are supposed to go into space in huge swimming pools, which are known as neutral buoyancy labs. And one lab is in Houston, Texas. So, and that they do to make them accustomed to weightlessness. So these tests NASA conducts before the astronauts go into space. So only difference between space and water, water there is a drag. Though they are floating and weightless, they cannot move around easily. But in space they float, but they can move around easily because there is very, very less drag in space. This is the only difference. So,
Well, yeah, I think that's actually a fairly interesting point about gravity. That NASA does use these large swimming pools to effectively negate gravity, and it actually does a really, really good job of emulating that situation, so that they can train their astronauts, and that they basically don't feel the effects of gravity under those situations, as if the effect had actually been largely neutralized.
see, this is another reason which supports, which supports the theory that there is no gravity. Why? If gravity was there, even at 100 kilometers altitude, their weight should have been around 90-95% still. They should retain their weight. But within a kilometer, suddenly they become weightless. This is not possible as per gravity theory. As per gravity, the weight will reduce as per the inverse proportional law, so that at 100 feet, 100 kilometers, their weight should be less by only about 5 or 10%. They cannot become weightlessness. It defies gravity then.
All right. So, do you guys have some questions about this? I think this is a pretty radical theory here.
This is Jack Kirkendall. This is one of the more exciting ones that I've wanted to listen to. There are several people whose work that I have studied that go right along the line with what this gentleman is saying, and a person named Xavier Borg and a person named Francis Viren Fernandez both have pressure theories. Xavier Borg and have pressure theories for gravity with all of the proof that it works. And it's basically, and Fernandez and Borg both came up with the basic particle of space, which is mc square equals hf. And so you have h over c square, and if you solve that, it'll be something to the minus 51, and that is the basic particle that makes up space. And it's if you get the mass of it, it's to the minus 9 kilograms, and it is so massive that it interacts with all particles and does not produce any heat because it's above the UV spectrum. And basically what gravity is two objects of mass, and when they get close to each other, the space in between them has less of this minus 9 kilogram particle producing force between the two of them. And so objects move together because there's more pressure on the outside than the inside. So there is no force involved in gravity. It's just that when two objects come together, the space between them has less force because of this. And they are fairly sophisticated theories, which I have one of them on my website, and I also have all of the calculations for this particle, this single particle creating all of mass. So this is really exciting. I would like to see some of his mathematics, if he has any, and keep following his theories because they're kind of exciting. That's all. Go ahead.
Yeah. Can I reply?
Yeah, please.
Yeah. See, I'm basically only I'm not a scientist, I'm not a professor or anything. By chance, after watching a TV program for 5 minutes, where they were showing Einstein's theory of space-time. So there in that on trampoline and that ball and all that I saw. So that was really shocking for me because I did not know about this before. So from then I started researching. Otherwise, I'm not a professional scientist, professor, or anything. I've been doing research of my own interest from the past 4 years after that incident. And in these 3, 4 years, I've come to know so much of things. And that is why I wanted to make a book, and I've made a book. So here only my observations I'm putting into my perspective. So basically, what should I say, physics without mathematics. So only whatever I'm observing, I'm drawing my conclusion and putting it in front of you. So how you calculate what is the mass and this and that, that is not my, I mean, I'm not so with that. Like you've seen my videos, nowhere I'm using any mathematics. Only what I'm observing, I'm putting it in front of you so that you can do your own calculations and come to your own conclusions.
Franklin, could I get you to go to symmetrymath.org and open up a page? This will only take a minute or so.
Sure, let's do that.
Symmetrymath.org.
All right. Let me get that up here. Symmetrymath.org. Okay. Yeah, this is your page.
Yes.
Let me share that. All right. Where would you like to go?
Click on matter.
Matter.
And go down to mass is frequency. Go over to, and now click on the right side where it says download file. Down here it's an orange color at the bottom. Mass, keep coming down, 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 right there. Click on that. And here's the calculations. So if you'll page down through there, you'll see I'm taking this basic calculation. This h over c squared, this 7 to the minus 51 kilogram seconds is, and Professor Konorev has shown that mass times the radius is equal to a constant. And so all mass comes from this one particle. So go on down. So you have a formula. So just keep going on down. Keep going. And here's where the formula comes out. You now go stop at the top. Go back up to the very top of this chart. You need to see equation here. Right there. Frequency is mass divided by h over c. So you can go back and take every known mass of particles we've done, plug this in, and get the frequency of that particle for every known particle. Doesn't make any difference what it is. This will give you its frequency and mass. And since you know the mass, there's an equation up there that can give you the radius, and so you can get mass, frequency, and radius of every particle with these two simple equations. So now go down some more. Just keep going down. This is just a chart of every known particle. And the one at the bottom, the Fernandez, stop right there. Can you move that back to go up a little bit? This is right there, the 180, 1.859223 to the minus 9 kilogram. That's the actual mass of the basic particle of ether in space. And everything is made from that. You slow this down and you get mass. So now going down some more.
So in relationship to what we're talking about, so you're saying that there is an ether particle, and that's its exact mass. And two people have come up with this, and a person named Xavier Borg has a complete theory of gravity based on pressure, and he also came up with this exact number that Francis Viren Ferdinand came up with, who's from India. Have you heard of the gentleman Francis Viren Ferdinand, since you're from India as well?
I don't think so, because
okay. Yeah, Francis has got hundreds of articles on our site.
I don't understand your terminology. Was it the less than sign, less than 9 kg? What does that mean? That's not
I'm sorry. I simplified mathematics. That's 9 zeros to the left of the decimal point. and the 27 above is 27 zeros to the right of the decimal point. Instead of putting 10 raised to something, it's much easier if you just put this way, and there's how many zeros go to the right or left of a decimal point, and it makes it easier to understand.
Okay, so that is exponential notation.
Yeah, in other words, you would see it as 10 to the minus 9, or
Okay.
10 to the plus 27.
All right, just as long as people understand that, because otherwise going, what?
Yeah, okay, I'm sorry, I should have said that.
Okay.
And now if you're going down further, if you can, this is Professor Karnarev's electron model, the torus, and the real radius is from here to here, and the magnetic radius is the closest possible. The R-mag is as close as the magnetic lines can come to each other in the middle, and the circumference of the R-mag to the radius of the R experimental is the alpha constant, the thing that's been called the hand of God. It's nothing but a ratio between the closeness of the magnetic field to the actual radius of the electron, and it applies for all known particles, photons, electrons, everything. This applies. So if you're going down some, I've actually done all those calculations. This is where you get the alpha particle. It's 2 pi times, so you get the circumference of the R-mag divided by the R experimental, and you get the alpha constant. And what's known as the classical radius of an electron is not a real radius. It's the radius of how close the magnetic fields come to each other. The real radius of the electron is a 2.2 to the minus 42. I'm sorry, to the minus 12, should be down there somewhere. The radius of an electron is 2.426 to the minus 12 zeros. Just put 12 zeros past the decimal point.
Now, what is the relationship between the fundamental ether particle and, say, Kanarev's electron model? I mean, where are the ether particles in this?
Going back up to the very first page, to that very first page, I showed you the 1.86. Sorry.
Well, I mean, that's a size thing, but that's not mechanically telling me, where the ether particles are in this particular picture.
The ether particle itself is go back up to the thing. Is a minus radius of it is like minus 42. It's so small that it interacts with every particle. No matter how small you get something, even the quarks and all of that, it interacts with everything. And so what creates gravity is this stuff interacts. It acts as a area. And once you get past the size of the Earth, only certain number of these particles can continue through, and this is what creates the pressure gradient. And the sun is far more massive than we think it is. Only a certain amount of this small particle is going through the sun. It's blocked by a large amount of the sun, and so there's a lot more mass in the sun than we calculate. If you're going down further now, go down to the next page after this one. Right here, stop right, go back to the top. Go back to the top, this up a little bit. This is the constant that Professor Konorev came up with, that mass times the experimental radius is equal to this constant. And you can plug this in and get mass, frequency, and radius of any particle. You get the experimental and the classical, the R-mag, and so you get both of these. And this is why the alpha constant is the same for all particles, because it's 2 pi times this divided by this gives you the alpha constant. And so this is why all particles agree with the alpha constant. They always change in the direct ratios.
I see things you have like up quark and down quark, but so far as I'm aware, they've never been able to isolate these things. So how do they even have
Well, they can give you the mass of it, and once I know the mass of this, you just plug it in the numbers. It calculates all the rest of it. They have, and these are probably estimated masses that someone came up with, because I just pull up stuff off that's in literature of estimated masses, and these are estimated masses of these things, and they all agree. They all come out to the exact same numbers. And if you go on down to the bottom, this chart here, you get the bottom quarks, the top quarks, what's called the Higgs, and the Higgs is not, this is almost totally irrelevant. It's got nothing to do with science. And this is the particle that makes up all of space. The bottom one I've got yellowed out, the 186 to the minus 9 kilograms, are 9 zeros to the left of the decimal point. That's what makes up all of space, and this is ether. And if you, I don't have Xavier Borg's pressure theory on the internet yet, but anyone who's interested, I can send you his pressure theory, and it takes you through all of this with the same calculations, and it's really hard to argue with his stuff. And one of the places that you also can know that he's probably talking correctly here is from the Kashmir effect, where he has shown that you put two plates close together, and as you get them closer together, they will just snap together, and you can't get them apart.
All right, so that's good enough. Anybody who would like to study this, it's on my site, or get these numbers and stuff. And so all I'm saying is this is why what this gentleman is doing is exciting to me, because I've already done all the numbers, and using this Kashmir line might be able to allow to do some more real calculations and come up with what this stuff is. So I really appreciate his work, and this is why I come here, to get other people's thoughts and theories on things, and this one's kind of exciting to me. Well, one of the interesting things he's saying is that this ether doesn't exist at ground level. I mean, would you agree with that?
No, ether exists everywhere. There's no such, ether is so small and so massive that it interacts with every single known particle, and it's only when two particles come together that has enough mass to block some of these massive particles coming through, that you actually get a pressure gradient, and that's what gravity is. And when you get larger than mass, larger than the Earth, it's when you really start blocking off. And so this also explains dark energy, dark matter, and the stuff they have, because everything is much more massive than calculated using current equations.
So then you have a conflict with our speaker then.
No, I don't have a conflict with him at all. I think everything he's saying is correct, that ether exists, and that there's a pressure differential there, and it's quite possible that you can use this pressure differential to create free energy. And the Xavier Borg has suggestions on how to do it as well. I don't think you're going to be able to go up and put it in a bottle, because it's way too massive and way too small. I mean, it's so massive and so small that we don't have anything that can even approach measuring it. It's sort of like Aristotle's experiment of, going in a cave and grabbing some photons and trying to capture a photon.
Okay, can I ask a small question?
I'm sorry?
No, can I please ask you one question?
Sure.
Okay. Now, in my animation, I've shown that at 120 kilometers altitude, a spacecraft like the space shuttle, which weighs more than 100 tons, is bouncing away into space, just like a ping pong ball. And as per theory, at 120 kilometers altitude is nothing but a vacuum. So how can something bounce up in a vacuum and go away? One. Second, why does heating start at 120 kilometers? The air exists, the actual heating due to air starts below 80 kilometers altitude. This can be found from the reentry mechanics. So there it is very clearly stated that the actual heating due to air starts below 80 kilometers altitude, to be exact 74 kilometers from the Earth's surface. But here we are having a very unique thing happening at 120 kilometers.
I can help. Yeah, I can help just a little bit with an answer. This is really the first time I've seen your work. I haven't had any time to study it. But Professor Konorev again has shown what heat is absorption and emission of photons by the electrons in atoms and molecules. So what's happening at the Kármán line above it, where there's no heat, there are no photons being absorbed by the spacecraft, therefore there's no heat being produced. When it goes below the Kármán line, the electrons in both the atoms and the molecules start absorbing photons, and that's what heat is. And so above the Kármán line, it doesn't absorb photons, and so this is why you have no heat.
No, but actual heating is occurring at 120 kilometers altitude. When the spacecraft penetrates, it heats up, fantastic. It goes up to 1,500 degrees centigrade. And the beauty is the heat remains constant, and between 80 and 100 kilometers altitude, there's absolutely no heating.
Exactly. So above that is not absorbing photons. So the only way you get heat is you absorb a photon. So in some fashion, it is not absorbing heat above the Kármán line. And this is what's kind of exciting to me. I'd like to see if I can figure out why. You only get heat when photons are absorbed by the electrons of atoms and molecules. Outside of that, you get no heat. This is why there's no heat produced with gamma rays and X-rays, is because they're the particles don't interact with the outer electrons, which produce heat, and so the 1.86 to the -9 kilogram particle is so small and interacts with everything. It produces no heat, and this is why this pressure gravity theory is correct, because all the ones in the past produced heat, and this is why it was dispelled by all scientists.
Okay, what about the bouncing? If the angle of attack is even slightly less than 40 degrees, the spacecraft bounces back into space. So this is a physical phenomena. So how do you explain it? It is similar to how
I would say it's similar to like water. So you've got water above the water. So when you put a photon in at a certain angle, it'll bounce back. And so it has to do with some sort, since there's no heat involved, this is the interesting part. There's no photons being absorbed by that spacecraft when it bounces off of there, because there's no heat produced. And so that's the really interesting part to me right now, is how can that be? Anyway, don't let me interrupt anymore. Go on with your thought and talks, because I'd like to listen to more of your stuff.
So my theory is very simple. I believe in what our ancestors said. The universe, the space is filled with this substance, ether, which is a homogeneous elastic substance. Its density is very, very, very less. When when you take the space between, say, two stars like our sun and a nearest star, its density decreases as you move away from a celestial body. And why density increases like you put in a bucket of water, if you put an object, there is displacement. So in that manner, celestial bodies displace the ether, due to which the density is highest just above the celestial body and decreases gradually as altitude increases. So for me, this is a physical entity. This ether is a physical entity. We can collect it from 100 kilometers, above 100 kilometers. We can physically bring it down, and if we compress it, we will get a transparent rubber-like substance. Similar to how when you compress gases, we will get liquid. We will get the elastic rubber-like substance, transparent. That is my feeling. It's a physical entity. It is there. It is real.
I agree 100%. It is the only problem I have with it is that it is so massive and so small. We don't have any form of an instrument to even remotely come close to measuring it. And again, it's like Aristotle trying to catch a photon in a bottle, and he had nothing at that time to measure catching a photon in his bottles. And so we're pretty much at if this is the thing I'm talking about is correct, we're at the same place. We just don't have anything that's capable of measuring something that massive and that small. And but I'm still really interested in your theory to see what I can come up with.
My theory is based entirely on the theories of the earlier people like Sir Isaac Newton, Leonard Euler, and all these people believed that the pressure is because both repel one another. The matter contained in celestial bodies like our Earth and the ether in space, they repel one another. That is why this 100 kilometers distance, why do these phenomena not occur below 100 kilometers? Like water taking on a spherical shape, then weightlessness, microgravity, all these happen exactly above the Karman line. Even if you come 1 kilometer below it, none of these phenomena occur, even though that is also a vacuum. At 99 kilometers, it is also an absolute vacuum almost, but none of these phenomena occur there. It is a magic line, like the Karman line is a magic line. You just go a few 100 feet above it and all these phenomena occur. That is why these SpaceX and all that, they are doing the space tourism. They have charged $250 per person to take them a few kilometers above the Karman line so that they will experience weightlessness. SpaceX, Elon Musk, and Virgin Galactic, they are doing this, but they have still not been successful. I don't know why.
Well, I mean, that is an interesting point you bring up there with these space tourism, because those people are not going into orbit, I don't think.
Yeah, that's what I'm saying. Without orbiting, they're going into weightlessness.
They're not going into orbit, but yet they're still somehow experiencing weightlessness.
That is why I told in the beginning, see, NASA trains people in the water to experience weightlessness. So the same thing is happening in space according to me. Otherwise, suddenly you cannot lose your weight. If weight was due to gravity, your weight has to decrease gradually with altitude increase. It cannot abruptly become 1000 above 100 kilometers immediately, because that's what NASA says. Microgravity, they say, but microgravity is 1,000th of the actual force. How can suddenly gravity become so weak? It has
Well, that would be my first question, which is, what reference can I get to tell me that that the gravity decreases to zero above the Karman line? Because I've never heard of that.
No,
I would totally not expect that to happen.
I'm not talking about gravity. That's why I'm telling. Why does this phenomenon occur? How can, if gravity was truly there, then the weight should not reduce immediately. It should decrease gradually, and maybe at 1,000, 2,000, 3,000 kilometers above the Earth's surface, then the weight would have become less, then we can agree. But here, at exactly 100, it is suddenly decreasing.
Well, I have no evidence of it suddenly decreasing. I have absolutely nothing. Nobody is telling me that happens.
No. But why do they float in a sounding rocket then? People inside the sounding rocket.
Do you have a reference?
Yeah, it is there.
Reference to that?
It is there in NASA website, European Space Agency website. That is why I told you about space tourism. This is exactly what they are doing. They will take them a few kilometers above the Karman line and bring them back. And once above the Karman line, the people inside the spacecraft will experience weightlessness. You can check up the space tourism, what exactly it is. Even there it is given.
I mean, they could be doing the same thing as the Vomit Comet, which is to go on a very, very wide arc, I suppose.
Parabolic flights.
If they're on a parabolic flight, we know they can experience the same kind of weightlessness.
So why go all up to 100 kilometers? Because it is happening, they are going there. Otherwise, what was the point in going above 100 kilometers altitude? No point.
Well, probably you can get a very, very large parabolic light, so you can stay
No,
weightless
no,
for several
they don't
minutes
make it.
versus
No,
15
sounding
seconds.
rocket. No, sounding rocket doesn't make any parabolic flight. Even if the spacecraft is ascending, people will be floating, and descending also people will be floating. But once the rocket comes below 100 kilometers, suddenly magically everybody will regain their weight. So this can happen only when buoyancy is present. Otherwise,
Well,
no other explanation for this.
that's what I'm questioning, because I would say, now I haven't performed this experiment, but I would say that if you sent a sounding rocket straight up, that as soon as it goes above the Kármán line, you would still feel the full force of gravity. That's what mainstream would say.
That definitely,
And
that is what the theory of gravity is about. So why
but
is
I
this
have
happening?
there's no evidence that above the Kármán line in a sounding rocket that you would be weightless. I'm saying there's no evidence that I know of that.
You can read the space tourism, you can read the sounding rocket experiments in ESA websites, European Space Agency, in the NASA websites. These are called suborbital flights. They just go up and come down. But their experiment is done always above 100-kilometer altitude.
Now, you have information then that NASA has verified that the rockets bounce off at this Kármán line. That's on NASA sites.
Yeah,
Yeah,
everything
that
what
definitely exists.
I've taken from NASA, ESA, and Wikipedia. And I've
Okay.
checked up not once, but a number of times, maybe hundreds of times. Only then I have written it. This is not my imagination. This is what is information is available on the websites of NASA, ESA, and this bouncing back. You can read this spacecraft reentry mechanics. In that, this topic comes up.
Okay, well, I'm on the ESA website. Am I sharing that with you guys right now?
Yeah, please go to sounding rockets.
So I'm on the ESA website, and if I go search here and I put sounding rockets,
Yeah.
let's see what it comes up with. Because I just have a lot of doubt as to there's any confirmation that a sounding rocket above the Kármán line experiences weightlessness. So here we have some everything we have about sounding rockets. So it's like the history of sounding rockets. So where should we go looking to see some evidence that above the Kármán line they've experienced
No,
microgravity or low gravity?
no, that is why they go up. No, otherwise they will not. There is no use of sounding rocket. A sounding rocket always goes above 100 kilometers and experiences microgravity inside it. All objects and people inside a sounding rocket, which are not attached, will begin to float.
Well, let's search for sounding rockets microgravity. Okay, here's something. They've mentioned something here. Rocketing to weightlessness with sounding rockets. Okay, so maybe this is something.
Yeah,
These flights can carry blah, 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 with up to 13 minutes of microgravity included in the ticket. Okay. Once the rocket motors shut off, the experiments enter free fall, even though at this point they are still heading upwards.
upward. How can free fall occur upwards?
On a downward arc, parachutes deploy and gravity takes over once again, lowering the experiments to the ground with impact speeds of around 8 meters per second. So these are definitely sounding rockets which do experience 13 minutes of microgravity. Okay, so there you have it on the ESA website. So if you want to go,
Could you send us that URL, because I can't get it off of here. Could you post that URL you have there up so we can write it down? I'd like to look at this.
So I am going to put that in the chat there.
Okay.
So you can look it up.
Good, thanks.
All right, so very good. So we have some independent evidence of what you're saying there, that sounding rockets can in fact experience microgravity and that curiously enough, even while they're heading, that the microgravity occurs at the time they shut off the rockets, even though it's still going
upwards. Yeah, that is a beauty.
Now, I do know that they do have the fall towers, and that they do a similar thing. That as soon as they fire the projectile upward into the drop tower, they begin to experience the microgravity almost immediately, and actually during both legs of the flight. So actually, you don't have to be above the Kármán line to see that phenomenon. Now that's weird, but that's something you may want to consider, that these drop towers also experience the microgravity on the up as well as the downward trajectory, but clearly done on the surface of the Earth. Let me see if I can find some information about that, because they have some videos on like YouTube about how these things work. So that might be an interesting point, that maybe these things do happen, but maybe they don't require the Kármán line.
There are only 3 ways of achieving microgravity. One is by sounding rockets. Second is by parabolic flights or vomit flights, what you say. And the third is, of course, orbit. Sorry, not orbit, free fall. When you are free fall also, you are experiencing microgravity. These are the 3 ways. Even this is available on the NASA website. 3 ways of achieving microgravity. 1 by sounding rocket, 2 by free fall, and 3 by vomit aircraft.
Let's see here. Let's share this video here.
To get just 1 more second's worth of free fall, you would have to build this tower half as high again. Unless you use something really clever, start by going up.
The experiments are installed into a drop vehicle. That's the experiment itself. It's all the measurement and diagnostic tools. It's a computer controlling it. We throw it upwards with up to almost 30 G for 200 milliseconds, and then into 0 G for almost 10 seconds then. And the deceleration finally by the end of the experiment has a value of about 35 to maximum 50 G. It should be very accurate, because you can imagine if the energy is too large, then we would hit the ceiling. We would destroy our vacuum containment, which is the most delicate element we have in our house. We almost perfectly balance the center of gravity to the vertical axis of the capsule by adjusting some counterweights at appropriate locations in the capsule. The experiments are in fluid mechanics, it's in combustion, it's in fluid handling, it's in biotechnology, it's in physics and astrophysics, it's in fundamental physics, so almost any discipline.
It's a little counterintuitive, but the capsule really is weightless all the way up and all the way down. The forces acting on it remain the same, even as it changes direction relative to us. So, here we go. Launch time. The slingshot will fire, and in the 9 seconds that the capsule's in freefall, an 8-meter deep pit filled with polystyrene pellets will slide in over the catapult to catch the capsule. Hopefully. Thanks to everyone at the University of Bremen, at the Drop Tower, and to all the researchers who are testing here today. Pull down the description for more links about them and about their work.
All right. So don't you wish you had the money to do that? Right? But now I'm not so sure that I really understood their explanation for why is it you experience weightlessness both on the way up and down. I think it has something to do with as soon as you get any object which is falling or moving on its own inertial path, free of gravity, that that you get this microgravity situation. But that is really weird. That when they take that cylinder and they accelerate for like 9 milliseconds at 30 g, but as soon as they stop that acceleration, you're in microgravity. As it goes up and slows down, and then you're back in, the whole time is microgravity. So what do you think of that? Is that another point of data that we can add to this whole question?
Yeah, you can add it. It is a valid point. But this is not only about weightlessness. There are so many other phenomena which occur only above the Karman line. For example, the spherical shape, water, any liquid in space which is above 100 kilometers, suddenly takes the shape of a sphere. So why does it happen?
Well, I think they should do that same experiment inside that drop tower. I mean, I would bet that it would form into a sphere.
No, it will not form. I feel because
there's only one way to tell, I suppose.
No, the biggest problem is every one of us are so 100% sure that gravity is there. We do not think otherwise. See, the drop tower, what you showed, it's a beautiful place where this experiment can be done. Like what I told you, I mean, in my earlier gravity animation, we made an experiment free fall. This can be done here because here they are they're conducting the experiment in a vacuum. So gravity is almost not present during free fall. So they can do those experiments here. But they don't do because nobody doubts gravity. Everybody thinks gravity is there. If they do, then they'll know whether water will become sphere or objects will start floating. All this they can find out. But nobody is conducting these experiments. They are conducting other experiments.
Well, now you know that device exists in the world.
No, it is there.
Maybe you can go contact them and say that, hey, I would like you to do this experiment.
There are 10 to 15. One is in the US, Marshalls or something it is called. One in Germany. Even Chinese have one. So many of countries have got these drop towers. And I've mentioned in my earlier video that they should conduct it because they have the facilities and only there the accurately it can be measured. But they are not doing it. Maybe I will send them a mail or something. Or you can do it also.
Send them a mail. Send them this video. Say, we're working on this. We're interested. And if they need to justify their existence, so they perhaps would be interested in cooperating with amateur scientists like ourselves just for something to do. I mean, actually, looking at your other drop tower experiments, the one that I didn't understand was that you had a little like lever kind of thing, and one of the experiments showed the lever was actually attached to a spring, and when it dropped, that was the only one where it looked like it was
going up.
It was extending this. What it was like going. What was that? Because I couldn't understand that. I couldn't understand what was going on in the video.
Here because that was made long back. It was not done in a professional manner. But the logic behind this is this. See, during free fall, everything becomes weightless. So we have a fulcrum which is pivoted exactly at the center. So when it is stationary, it will be horizontal. Now we keep a weight on one side, only one side, so that side comes down. During free fall, since the weight becomes zero, the fulcrum should become horizontal again. But nowhere it is happening in the free fall. That is what I was trying to explain. It is always remaining inclined. It never went into the horizontal position. So suppose its weight was becoming zero, the fulcrum, that rod should assume the horizontal position.
See, I'm seeing whether I can look up that video, because even though the videos are not very high quality, they do show how you perform the experiment, and you could, I can actually see inside and see what you were doing there. Yeah, I've got those videos somewhere here. So what do other people think? This is a science chat. I want people to be chatting, not unless you just totally agree with everything the speaker is saying, which I would find hard to believe since this is a very diverse group. Otherwise, I'm going to start picking on people.
Just in my opinion, I really like what he's doing. He has information that is incredibly useful for putting real science to it to see if it's correct or not. And the obviously thing you do is you either verify it or you prove it incorrect. And if you verified it continues, you prove it incorrect, then you move on. I need time to study what he's doing. I'll relook at his videos probably 20, 30 times and see if I can, like you said, I don't really understand what he's doing at this point. It's the first time I've seen it, but it is incredibly exciting.
All right. Now, I have been sharing this before. So he's got a book on Amazon, and for only $11.99, you can get his book. And I noticed that Pal, he's actually got his book. He's reading it. So and that's very cheap. I mean, I think that is actually the cheapest price to get a book published in Amazon. Is that right? That basically you're not making any profit off of this, I don't think. Or the Kindle version can be had for even less, only $2.99.
In India, it is still cheaper. It's only about $2 the book.
Would you? I'll see if am I still up.
And actually, you can look inside the book. Actually, one of the little secrets. I don't know if you know this, but it's like basically you can read most of the book if you kind of scroll through it and you search for stuff. So you can see like a lot of the introduction, and you can search for specific keywords. Actually, I think the whole book is actually online, but it's just kind of a pain to read it this way.
Would you again one more time, please, expound on your science background? And are you doing this strictly from logic, but not using any equations and stuff? I'd like to know what your science background is, please.
No, basically I'm a businessman. I am a technical person. I have a manufacturing unit. I manufacture leather watch straps and aluminum anodized buckles. So this is not my field at all. I am not even slightly connected with it. Like I told you, after watching a science, TV program, which is called Through the Wormhole with Morgan Freeman. It was on Discovery Science Channel. It was somewhere around 2012, I think. Maybe 5 minutes I watched that program. Then they were showing that trampoline and all sorts of space-time and all that they were explaining, which really made me sort of curious. And out of curiosity, I started doing research on my own interest. And I came across vast amount of information, which compelled me to write a book. So my book is that not at all, it does not have any mathematics, theories, equations or anything. It is purely theoretical. What I have observed and what I have put into the book. And as per me, the atom is not 99.99% empty space. The empty space is filled with ether in a condensed form, just like René Descartes, Newton and all suggested. So the atom consists of protons, neutrons and electrons, and the nucleus is embedded inside this, condensed ether. So that is why we are all full solid and everything. If atoms were 99.99% empty space, just imagine we should not be existing. So whatever has occurred to me, whatever I could find out, I've put it in thought. My thoughts have put it into this book. That is all.
Well,
But
I congratulate you on what you've done. That's quite incredible research and coming up with something that's very interesting in science. Thank you for your presentation.
thank you, thank you.
Yeah, man, I like your quotes here in your book here. Even if you may not agree with your theories, I mean, a lot of dissidents do point out a lot of good points about how mainstream is being biased. Here's your quote by Carl Sagan. Sagan says, "I think is a kind of intellectual chauvinism to assume that all the laws of physics have been discovered by the year of our meeting. Had we held this meeting 20 or 40 years ago, we would perhaps have erroneously drawn the same conclusion." Those are great quotes. I think that the book is worth reading just for that kind of stuff. Now, if only I had so much time to read books. So I barely have enough time. I can't even answer the emails that I get from the science group. Basically, I've got like 6 or 7 drafts that I have to answer, but I just haven't had any time to do it. In fact, the 2 hours I spend here is probably the most time I have to spend on doing science-related things. But you're hitting on a lot of my own favorite topics, which is say the ether and things like that. Now, if no one has any other comments, I would agree with a lot of, for example, you said that we're made out of, say, condensations of the ether. But in order for that to be the case, then we would have to be made out of, say, the ether particles.
Yeah.
So, but you're saying that there's an ether, but you don't know exactly what that is.
There's a physical entity. That much I'm sure. It is a physical entity which is elastic in nature. If we can bring it down and compress it, it will assume this shape. I mean, it will become a rubber-like transparent substance. That is my opinion, my presumption, my belief.
Well, if we're made out of an ether condensate, right? That means we're made out of the ether, right?
There are 2 different kinds of matter. One is the energy. See, actually, anything, you take any object, there are 2 aspects to it. One is the energy part of it. The protons, neutrons are the source of energy. Then there is the physical part of matter, which is mechanical in nature. That is endowed by ether. Because only proton, neutrons, electrons constitute only 0.001% by volume of an atom. That means 99.99% of an atom is empty space. So it doesn't, there's no logic in that. Yeah, we have studied it in school, we believe it. But when you think in a rational manner, how can empty space assume solid form, liquid form?
Well, I personally don't believe that myself. I think that, the only reason why we think that it's so much empty space was due to an experiment performed over 100 years ago by some bleary-eyed graduate students who were probably just trying to please their professor.
Robert Rutherford.
And I believe that, that whole, Michelson-Morley scattering experiments is just revealing what we call the scattering cross-section, which is you just look at what gets reflected back from these experiments and you calculate what is the smallest solid target that could return that result. And of course, it's going to be small. So it's like if I fire BBs into a chain link fence, that chain link fence may be 10 feet by 10 feet. And it completely fills the 100 square feet that you're firing it into, but the scattering cross-section might only be like a solid steel plate 1 inch square. And so you would be concluding that the thing that's in that room is 1 inch square, when really it's 100 square feet. It's 10 by 10 feet. So that's kind of what I think we're doing with all these scattering experiments in atoms, is that the scattering cross-section is not the actual size of the object you're measuring. It just isn't. and that the actual size of an atom, I mean, I have pictures of them doing this with scanning electron microscopes, and they fill the space between the atoms. I mean, you can take a look at them. They look like Lego bricks. They're so space filling. So and they have specific shapes. So yeah, I would disagree with this idea that the atoms are like 99.9% nothing. You know, that I think we already discussed that. It's like, you know, why is it I just can't stick my hand through the wall? Because if it's 99.99% nothing, then there shouldn't be anything to stop me from putting my hand through the wall. But yet there is something, and if we look, like I said, if you look at this atom by atom, we can see atoms now. You can see a solid line of something there.
There's no emptiness.
Yeah, there's no emptiness. There's fillingness, I would say. But getting back to what you're thinking the ether is, I mean, I'm more of a pragmatist. For me, it's not satisfying to say that the ether is some mystery substance. See, for me, if I believe that we're a condensation of the ether, that would mean what? That means we're made out of the ether particles, right?
No.
And what are we made out of? Well, from the mainstream, we know we are made out of electrons, protons, and neutrons primarily, right? That's what we're made out of. So if we were to stick with
both are there. See, the protons, neutrons, and electrons, they form the energy part. Now you take a vehicle, say a bus or a car, motor car. You have a physical car, then you have gasoline to drive it. There are two totally different things. Without the car, gasoline has no use. And without gasoline, the car is of no use. So you need both. So similar to that, an atom, the energy part is supplied by the protons and neutrons. They are actually tiny nuclear bombs, you can say. They are compressed energy. Compressed energy. That is how this nuclear fusion and the nuclear fission occurs. No? They are splitting the atom and the energy is released. So each proton or atom, the nucleus of an atom is a tiny nuclear bomb. Once you split it, that vast amount of energy is released. But according to mainstream scientists, an atom's nucleus is held together by the strong nuclear force. But according to me, it is same, just as the earth and the ether is repelling, the nucleus and the condensed ether repel one another, due to which the nucleus is kept in a compressed state. So according to me, the atom has both proton, neutrons, electrons, as well as condensed ether. Ether gives physical shape and mechanical properties to matter, whereas
what is this ether?
It's a physical substance. It exists. That's what I'm telling.
And what's its relationship?
Collect it from space. That's all.
See, this is the part I don't like. For me, I want to come up with an actual, recognizable explanation for what this substance is. So, if I think I'm a condensation of ether, then that means fundamentally the components that make me up is the same components that make up the ether. And the smallest components that I'm made out of is positrons and ultimately electrons. So positron is the positive opposite antimatter component of the electron. So these two things we know exist, the positron electron. So and this is my favorite theory. I call it poselectron theory. And I'm just telling you how I solve this problem. And that, I say, yeah, there's totally an ether, but my preferred embodiment is to say that that this C is made out of a positron electron C, just dipoles. So that would mean that it would be true that I am made out of exactly the same stuff as the ether, which is electrons and positrons, and that things like protons, there aren't any quarks. The way I explain protons is that they're just two positrons and an electron. I mean, what could be simpler than that? There's three things in there. Two of them are positively charged. One of them is negatively charged. That's a proton. But if we do have this space which is filled with those electrons and positrons, then at least I can tell you, what that ether actually is physically, and experimentally, we should be able to go find that. And we know about positrons, we know about electrons. So experimentally, I don't have to retreat into this I don't know what the ether is kind of situation. I can tell you, at least from my preferred embodiment, that you go look in some vacuum jar, you can break out the individual positrons, electrons. We see that in pair production. But you should be able to conduct some other tests that genuinely tell you that space has all this mass in it, right? People try and tell you that, the ether is massless, and it's like, well, how can that be? But that's say my preferred embodiment of what I think the ether is. So I'm definitely an etherist. I'm right there with you, but I just have a specific embodiment.
In my book, I've written about antimatter. According to me, ether itself is antimatter actually. Nature has converted one type of energy into the protons, neutrons, and electrons. The other, what you said, positrons, that is antimatter, has been converted into ether. Ether is nothing but antimatter, according to me. There are two types of matter. One, the matter which exists within the nucleus of an atom, and the other matter is ether.
Well, we know about other antimatters, like we can create antiprotons.
But why doesn't it exist? There's no antimatter we have found. Only they are producing it in the lab, in the sun. But antimatter doesn't exist like matter does. Like ordinary matter.
That is certainly an outstanding question as to why antiprotons aren't more abundant. No, I mean, actually, according to the way I'm thinking about it, is that a proton is stable because it just likes to be that way. Two one electron surrounded by two protons, that seems like a reasonable structure. It probably forms like proton, electron, proton. And it's probably reasonably happy, and that's why it's stable. But I can't see, but equivalently, the antimatter, the antiproton, which would be a proton in the middle and two electrons on either side, should equivalently be stable. And I would actually predict that it would seem like a proton and antiproton shouldn't annihilate each other because they're both mutually stable. But I think they do annihilate each other. So that kind of like blows my theory. But see, there's always these problems, right? About why is it that the antimatter doesn't exist as prevalently or is as stable as the regular matter?
I have a theory on that one.
Sure. What's with the antimatter?
I think I explained that a couple of years ago to you when I was on a road trip to California and a conference call. But basically, the difference between antimatter and matter is the precessional direction of the matter and antimatter. So antimatter would precess counterclockwise, and matter would precess clockwise, and you can't have the two exist in a universe. That if the entire universe processes counterclockwise, you would consider that any component within that universe would process clockwise. It's kind of like the Coriolis force. You have a typhoon in the southern hemisphere and a hurricane in the northern hemisphere, and it's because the Coriolis force gives it a direction. But if you have a globe that was, instead of just spinning, you had a globe that was spinning and processing in a counterclockwise direction, all you would have is typhoons. If you had a globe that was spinning and processing in a clockwise direction, all you would have is hurricanes. And so if the universe is processing in a particular direction, then all the content of that universe would be processing in the opposite direction. And that's my theory on it.
Okay, so basically antimatter, it has something to do with the direction of spin.
Right.
and that these things are spinning oppositely.
Right, and since the entire universe is spinning and is not spinning but processing, so a simple spin, you can look at a spin. You can look at the spin of a clock, and you can look at it from the front of the face, and it's going clockwise. And you can look from the back of the face, and it's looking counterclockwise. But if it possesses an axial spin in two directions, in two planes, then you can't look at it. You can always only look at it, no matter how you look at it. It's always going to be processing in a singular direction, no matter which direction you look at that object from. So if the universe is not just spinning, but is processing in a direction, then anything within that universe that's created would be processing in an opposite direction. And that's why we can create a object that spins in the opposite direction, like a positron, but its life expectancy is not good because it's in an environment where everything around it is processing in the opposite direction, and it conflicts with everything, so they disappear. So consequently, we wind up with a universe that the contents of that universe is all processing. All the electrons and protons are processing in the same direction.
May I take a turn?
Sure, go ahead.
All right. We kind of are boxing ourselves in to suggesting that either we're made out of the ether or we're not made out of the ether. And there's a third possible solution I'd like to suggest. So the best analogy I have for it is a tsunami. When an earthquake makes a tsunami in Japan, the tsunami wave travels across the ocean and crashes against the shore of California, for example. And the question that needs to be asked is, what is a tsunami made out of? Because the water molecules is not the right answer, because when the tsunami crashes on California, it's different molecules that are actually hitting the shore. The molecules have not traveled from Japan to California. So what water is made out of when it's just sitting still is water molecules plus molecular vibration. When the tsunami travels through it, it's a reorientation of the vibrations that's traveling, not the water itself, just the reorientation. I would suggest that similarly, matter, is made out of reorientations of the vibrations of a molecule that exists. And so we're not made out of the molecule, we're not made out of vibrations, we're made out of constant reorientation of those molecules and their vibration. But when I say molecule, I'm talking about a Planck scale physical entity that feels existent.
Yeah, well, I've got a similar theory, and I think everybody knows it, and it's basically that there are, even the Planck molecules don't exist. It's just a continuum, and the only thing that exists is variability and fluctuations of tension within that continuum.
Well,
and those patterns of tension, which are wave patterns, can form spherical wave patterns, can form a spherical wave pattern with a transverse wave pattern revolving around it, and so on. But it's all a tension within a unified field or a continuum. The particles that you're saying, the Planck particles, aren't necessary, because even between the Planck particles, you still need a connection between them, a force between them, for them to react with each other. You have to have the tension. So basically, I eliminate the tension or the Planck particles and go straight with the tension completely. And it's just a pattern of tension that we recognize as being existent. So we have, in fact, taken into account that third option. It's just that we've gone to an extreme and eliminated the need for the Planck particles. The Planck characteristics of the universe is basically because these waves are all of a consistent frequency, differing wavelengths, but the consistent frequency. So in order to add or subtract anything from this, you have to add or subtract an entire wavelength at a time for everything to stay in harmony. and therefore you get your quantization characteristic, not because there are individual particles that are unique that add or subtract, but because the energy can only be added or subtracted in full wave increments. So there is a similar theory to yours, but it doesn't involve particulate material whatsoever.
When we remove the suggestion that there's any material whatsoever, then we introduce a problem. I think if you have watched, there's a video by Neil Turok. He's the director of the Perimeter Institute, and he says.
Well, first off, we didn't say that there wasn't any material whatsoever. We said that the material was non-particulate. We said there's no parts to it. It's a tensionable material, but it's not particulate.
Right. So what I'm going to suggest is that if there are no parts to the particulate material, Neil Turok introduces the problem that if the universe is made out of waves and only waves with no substantial material at any level, then there's no reason for a minimum wavelength, at which point you can have an infinite number of waves in any point at any point in time. And if that's the case, the sun doesn't work. It mathematically it would freeze instantly because all of the energy could escape simultaneously. There would be nothing to slow down the escape of the release of energy. So we're asking what could the ether possibly be made out of? And I have a suggestion in that regard.
Right,
a shaped Planck particulate.
You still run into the problem that Planck particulate has to be attracted to another Planck particulate in order to get anything to happen.
That's only a problem if you believe in forces. If all of the universe is absolutely filled, i.e. there's no empty space except for the negative space in between the Planck particulates, then you can explain the ether without having to resort to actual uncontained energy or forces that attract at a distance magically across a void.
Right. Well, by getting rid of the distance and not having the void between the Planck particulates, or by getting rid of the Planck particulates. The problem with the Planck particulates is you still need tension to create a wave. You can't create tension. You can't create a wave in a particular media that has no tension between the particles.
Well, we were talking about the Coriolis force and precession. So
right.
If a Planck particulate exists and fills existence, then, and if all of it is in constant rotation and in constant oscillation and in constant bounce, because it has to, because of its shape and its interactions with its closest neighbors, then perhaps what exists is a ether that's always in motion, and everything is made out of either an increase in the motion or a decrease in the motion, not made out of the ether itself. So if everything is, say, like traveling at almost like the ether particulates are in motion at, let's say, double the speed of light, and then, well, I don't want to pick that particular number, but at some number of speed of motion, then everything is made out of an increase or a decrease to that speed of motion. So then forward and backwards aren't forwards and backwards. They're forwards plus a bit and forwards minus a bit, as opposed to being forward or backwards, because everything has an underlying motion to it.
You still run into the problem where you can't create a wave without a tension. without connection between the ether particles. And you definitely can't create a transverse wave 100%. You have to have tension between them. And if they're just free-floating ether particles or even ether particles that are up against each other, you cannot create a transverse wave in it. You can't actually create any wave in a medium that is totally floating free. It's much like trying to create a wave in a ball pit in a McDonald's play pit, for instance, Mick. Does that sound familiar, Franklin? You can't really create a wave in that.
Well, no, you
You
can't. I
have
mean,
to.
you can create waves between non-interacting particles by just pure collision.
You know, you can't. That's just it.
No, you can't. I mean, you have one billiard ball hits another billiard ball,
Yes.
and the billiard ball goes away. I mean, there's no tension between those two billiard balls at any time.
Yeah,
it's just
but
that one particle hits the other particle and it moves. That's how. So no, I would disagree that you need to have any kind of interaction between the particles to get a wave action going.
Well, I think you have to look at that a little deeper and put all the other billiard balls next to your billiard ball too, and surround it entirely with billiard balls.
Yes.
And wiggle, and try to get that wave to go to the other end of the pool table.
That's why perfect regular spheres cannot be the Planck particulate. And I have a shape that I'd like to show that I suggest is the exact shape of the Planck particulate, and that they are touching in a continuous series. They're under high pressure, so they have to always be touching. But they're not perfect regular spheres. They're wave deformed spheres. They have a wave shaped exterior, a geometry, a topology that's not a perfect regular sphere. I've just added a link in the chat that shows, but I don't know how to make it come up on the screen.
Well, if you put a link in the chat, I'll display it for you.
Okay,
so yeah, I can do that. I'll click on that.
The problem you come up with any geometrically shaped particle is if they have to fit together, they have to fit together in a matrix of some kind.
Absolutely.
And if they fit together in a matrix of some kind, then any energy you put into it is eventually over time going to follow one of the planar directions of that matrix. And the planar direction, that characteristic is absolutely not a characteristic of space. Space is isotropic. Any direction you go, energy will go as equally as easy in any direction. That can't be the case if you have a non-isotropic substrate.
What's isotropic mean?
It means that it looks equal in all directions. No matter which direction you go in, the energy will propagate equally. If you have a lattice structure like you're demonstrating there, then that energy will eventually follow those lattice structures, because diagonally from point to point is a different distance and different strength than it is horizontally from point to point. So it's going to have a tendency to follow the horizontal direction, the vertical direction, or the depth direction over time. And space does not do that. Space goes any direction equally.
Well, I would actually kind of disagree with that, because, we see this kind of diffraction kind of effects. And, I'm thinking that those diffraction effects, because you can get diffraction even through a single slit. You don't have to.
Well, you could get that, but you got to explain how a star, no matter which direction we look through space, how that star travels through that diffraction grating from there to here. If the entirety of space is filled with a grating like this, why is that starlight not following those grating lines over that great distance?
Because space itself is fine enough that it's
it not. It doesn't matter how fine it is. It doesn't matter how fine it is.
Yes, it does matter how fine.
No, it doesn't, because any fineness is still going to have that diagonal versus lateral difference over time. That diagonal versus lateral
I'm saying
difference.
Those things will only appear in that very, very, very small scales, such as if you're trying to put light through a thin slit, then those effects will actually take precedence.
That's your assumption, but that's not.
It will
That's your
cause the
assumption, but
photons
that's
to
not
only
true.
go into quantized locations. And so I'm thinking that single slit diffraction is evidence of the granularity of space, because the photons are not capable of taking every possible direction, that they can only take very specific quantized directions out of the slit. So that to me is evidence of the quantization, that diffraction grating does actually exist, because we get this quantization effect.
The energy is going to go down the path of least resistance, and the path of least resistance is going to be along the three planes of the grid. And when a star shines, it doesn't follow the three planes of the grids, or we'd only see stars in three different directions, and that's it from where we stand. And every time we moved, we'd change our perspective and we'd see a new set of stars that were aligned with that particular grid we were now in.
No, that would only be if the grid size was like huge, like if it was like 1,000 miles.
It doesn't matter what size. It doesn't matter what size.
Matter.
Well, you have to.
As I look at my computer screen, you could say that, well, I should be seeing pixels all over the place, because eventually every single dot of light can only be on or off. But the thing is that at a sufficiently high density, we can't see those pixels, and it doesn't matter. Everything.
Your computer screen is totally controlled by the computer behind it, and you can turn on and off pixels and give you a minute image of a round sphere. And besides which, nothing is traveling from left to right through that screen.
Yeah, but the point is the same. It's like you're saying that if I were to display a sphere on my screen, that I would see the jaggies.
If you were to take a crystal and put vibrations in the center of it, the vibrations would transmit out laterally, vertically, and depth-wise. And they would take those preferential directions.
All right, I'm agreeing with you. For example, if space was made out of cubes that were stacked like a Rubik's Cube, then everything would transmit planarly. Take a look at the shape in the bottom right corner of the image that's posted, and you'll find that it actually has every direction taken care of. Because of the wave deformities, it has an up left, an up right, and everything in between. And I'm not suggesting that we're made out of those, that we carry a sack of those around us. I'm suggesting that those are like the water molecules, and they're always in motion. And the motion is like the molecular vibration of water, and that we're not like the vibration, we're not like the molecules, we're like the tsunami that travels through molecules and through the vibrations. So first you have to take the molecule, the Planck particulate in the bottom right corner, fill space with them, and then have them all rotating, but because of their shape, as they rotate, they shift slightly left, slightly right, slightly left, slightly right, but they also shift forwards and backwards, and they also shift up and down. So they are like always in motion in every direction, as well as their rotation, and then we are going through them. We're not made out of them. But you shouldn't say, no, that's not possible, without examining the shape itself. Look at the properties of it. Look at the deformities and the offsets of the deformities, and imagine how a group of those would force each other to move a bit just to make a rotation. And so it's a combination of their rotation and their forced movement during rotation that creates the spin field, which is a jitter. And we're made out of this space. The spin field is like space-time. So we're not made out of the particulates. We are made out of a wave that travels through a wave. If you're familiar with Bohmian mechanics, the Broglie-Bohm pilot waves, that's what the spin field is. And the medium, the Planck particulates are responsible for the properties of the pilot wave. Because we were asking the question, if there's an ether, what could the ether be made out of? That's my suggested answer for what the ether could be made out of. Specifically, an infinite number of that exact shape in the bottom right-hand corner.
It's still basically a wave. I mean, there are two camps here, and one camp that you and Cornelius are expressing is that matter is made out of waves, or it's like our speaker is saying is that matter is made out of energy. That now this is where I have a violent disagreement, which is that this is taking away the physicalness of matter. That you're trying to say that because Einstein said E equals mc squared, that means matter is made out of energy and energy is made out of matter. That there is no actual physicalness to the matter. That matter is somehow like a wave, or it's Cornelius would say it's a specific representation in the tension field, or some people would say that it's a rotating vortex of something, of like energy, so that to release that energy you just disassemble the spinning vortex and then you get the energy out. Like I said, all of these things are trying to remove the physicalness of matter, which I disagree with. As an alternative to those kinds of theories, I present that matter is in fact matter, that it's solid, that when I pick up something here, that if I break this thing down into its smallest components, this is a Lego brick, and I can just take one Lego brick and I can take another thing. Now, eventually, if I keep on doing this,
now you got a Lego brick left.
That you will get a Lego brick.
No.
Really, that's what I'm saying.
That's exactly what you're saying. But I'm not taking away the fact that matter is matter. I'm taking away the fact that matter is particulate. Matter is a continuous energy carrier in which energy fluctuations occur, and those patterns of energy fluctuation are what we recognize as matter. If those patterns of energy fluctuations become extremely concentrated and strong, they can interact with another area of extremely concentrated and strong tension fluctuations. Those tension fluctuations can actually attract each other within this solid media. But what we recognize as matter, we recognize it only because it energetically interacts with other matter. So it only is one area of space that is tensioned will energetically interact with another area of space that is tensioned. Neither area of space is actually separated. They're all just a degree of energy or tension within that media, and there's still a media. The media just does not have to be. The media does not have to be particulate.
Are there any experiments that you can show that to validate your theory, or how many people are on board with you of your theory?
My theory I've demonstrated before, and it basically demonstrates is what you have to pay attention to is how tension behaves in a tensionable media. And you just have to say that if space is a tensionable media, then waves within that tensionable media can increase, decrease, self-focus, become resonant, and interact with each other in such a way that they behave exactly like gravity, exactly like electromagnetics, exactly like a neutron, exactly like a proton.
What experiment shows that?
The experiment is a thought experiment built up from the fact that you have just simply observed tension alone.
It's a thought experiment. Okay. Never mind. Go ahead.
Never mind.
I mean, everyone has a different opinion here.
You can observe tension, and you tell me you're trying to eliminate the possibility of action in a distance, and yet you keep on creating a distance. There is no distance. There's connection, and in that connection you can create tension. If there's no connection, then you lose that tension. And where there's no connection is in the center of every atom, molecule, and particle you can think of, is where there's no connection, because that's the one place that waves and energy cannot go through, is through the center of a particle.
Well,
Frank,
I still think you're taking away the physicalness of
The
what matter is.
physicalness is the entirety of the entire vacuum that we consider vacuum, is nothing more than a complete, solid, unbroken, tensionable field. That's physical. The reality is that within that field, the reality is within that field, we are nothing more than waves, like the tsunami, like the vibration of on the surface of a water.
That is what I totally disagree with. I totally disagree that we are in any way a wave in a medium. That is what I'm telling you takes away the physicalness of a particle. I mean, I'm just telling you what I think. I think that if you took this Lego brick apart, eventually you'd end up with one solid Lego brick, which has the exact same characteristics of the one I'm holding, which that it is solid, it occupies a finite amount of space. Physically, you can't stick two of these things together.
It's not solid. It's not solid. It is created by a packet of energy.
Nope, it's solid.
No, it's not.
It's this Lego. See? If it wasn't, then I'd be able to squeeze my Lego and cause it to disappear if it was not solid. But it's totally solid.
But Franklin, you know what neutrinos are, and you know that neutrinos are flowing through us all of the time by the trillions. Your fingernail has a trillion neutrinos going through it at any given point in time. So the question becomes, are neutrinos flowing through us, or are we flowing through neutrinos?
No, the real question is, what is a
I think
neutrino?
both is true.
Now, for me, I believe a neutrino is like a gamma ray, which means it's an energy. It's a very small, very specific, like a soliton wave. So we can register it coming through. We can detect these things, but they're not an actual movement of matter. So so that's how I explain neutrinos. Neutrinos are not actually matter. They are a wave phenomenon similar to gamma rays, but just smaller.
What are they waving through?
They're waving through what I call the ether, which is, for me, it's a positive electron sea.
Yeah. Well.
But I'm just pointing out that about the solidness, about the alternate. Because a lot of the dissident scientists do. I mean, I would say the vast majority actually agree with you that they want to make things like matter out of waves. They desperately want to do that because they can't deal with the concept that matter is actually solid, that it does represent something distinctly physical. And for me, I say that the electron is fundamental. I don't know exactly what electron is, but if I were to hold one in my hands, it would be exactly like this Lego brick in that it takes up a finite amount of space. It has a solid surface.
Yeah, an electron would be a packet of.
They would come together like Lego bricks. But once again, that is just kind of, I put that as a contrast because so much of the dissident scientists is, actually would agree with you that, matter is some kind of wave, that we're waves, things along those lines, or that the ether exists below the level of electrons. I mean, most of the dissident science community would actually agree with that. So I'm kind of the minority here that I'm saying that no, the electron, it's a solid, hard little ball. Physics loves to say that the electron is not a hard little ball, but
they call it I thought the electron was made of quarks.
No, in mainstream, the electron is not made out of quarks. The electron in mainstream is fundamental. I mean, protons are made out of quarks, but correct. No one would ever say that an electron is made out of quarks. In mainstream, no one has been able to break an electron into anything. It's, you know, we can't even tell what size it is. All we know is that it's there. It's a particle. It's not made of quarks.
It's a concentration of energy, which hasn't got a boundary.
Franklin,
well, I would say it's a solid particle. It does have a boundary, but you know, I don't have any experiments.
The solid particle has a boundary, but you can't sense that solid particle a foot away by another solid particle. And yet, the electron's field, an energy field, can be felt by another particle a foot away. There's nothing, but if it was solid, it certainly wouldn't reach out that far.
I just posted a video in the chat, and it's a 6-minute video by a guy named Neil Turok. He's the director of the Perimeter Institute of Canada. He does not deal in dissident science. He hangs out with the guys that work on CERN and all those other types of guys. And in his video, that's an excerpt from a hour-long video that's just 6 minutes. He says specifically, everything is a wave, but everything cannot be a wave, because if everything was a wave, the sun would freeze. Therefore, somewhere something must be not a wave. And he explicitly says that in those 6 minutes of that YouTube video there.
That's the kind of the contradiction, is that you always have this chicken and the egg kind of thing, which is, you say everything's made out of waves, then the problem is waves must always exist in a medium. And so what is that medium made out of? And is that medium made out of waves? And if that medium is made out of waves, then what medium is it waving in? And, you know, this goes on and on forever.
Yeah, that's why the final medium has no particles, has no parts to it.
And I suggest that it does, and they're specifically the shape that I showed you.
Right, I realize that. Like I said, it's an unnecessary shape and an unnecessary particle.
Because you're defying the logic, because if this medium has no particles, that means it is effectively a solid, and it has no motion that can be recognized inside of it.
Exactly.
Therefore, it cannot represent a wave. So
it doesn't have to have motion. It doesn't have to have motion to transmit tension. It has. You can't see it because there's no particulars to recognize the tension. But if the tension is increased or decreased in an area, then another area of tension will react to that and will combine. But you will not see it until that tension becomes interacting with other tension. You see things because your tension interacting with other tension patterns.
I agree with almost everything that you say, Cornelis.
Yes.
Sorry if I'm mispronouncing your name. The only thing is that you want to take away all particulates, and I'm saying, well, there's a particulate that does make sense.
Yeah, and I still need to take away particulates because of, like I said, the pattern does not lend itself to isotropic behavior, and because the pattern still requires tension between the particulates to make a wave. And particularly a transverse wave cannot be made in such a medium unless there's tension between those. And light is known to be a transverse wave, is understood to be a transverse wave. And even if not light, there are transverse waves all over the place. Transverse waves require tension. Utmost, foremost requires tension to do any of this. And tension requires connection. And
okay. So
regardless of how
it's the top of the hour here. And maybe next week we should talk about this, which is matter a wave or is matter solid?
Okay.
Although I don't know that, you know, there would be many people on my side saying that matter is actual solid.
I'm not sure who was it that I was speaking with anyway.
I agree with you. I agree with you, because according to me, matter is not singular. It is dualistic. It is both physical as well as energetic. So according to me, the protons and neutrons represent energy, whereas the condensate of ether is what gives matter its physical form. There's nothing like singular matter. Matter is dualistic in nature.
Okay, but in,
Just
in
like
the situation you say the condensation of ether, the description is what the real question is. What does ether consist of? Is ether particular or not? I think is kind of where we were going with the discussion.
Yeah, well, like I said, we are at kind of at the top of the hour
Franklin,
here.
I'm gonna agree with you. There are no experiments I know of that show that mass is not a particle. Everything shows mass is particles. The wave frequency stuff. There's nothing that shows that produces particles.
Right, but mass can be affected. Anyway, I think we are done with this hour. Was it Jack? Jack, is it Jack that's speaking?
Yes, Jack's on. Yes.
Okay, I'm not sure if I got your email address, Jack, or if are you part of the list that's constantly going around, or?
I think so. Yes.
Okay.
I get an email every week. So
Yeah.
yes.
Okay.
All right.
Well,
So,
well, not just that email, but I'd like to get your email. I don't think you're part of the list that I'm normally chatting on, so you're probably not privy to the discussion that I've been having. Thanks, Franklin.
You can always go on symmetrymath.com. That's all
.org.
stuff there. .org.
Symmetrymath.org.
Yeah.
He's got all of his stuff there. So, let me summarize. So, today we've had a discussion on the Kármán line, which is this line which is about 62 miles up, defines the edge of outer space. And so, what our speaker has asserted is that if you get above this line, you go weightless. So, and certain things happen. Liquids become spherical, and you can orbit. And we did go onto the ESA website to try and confirm that this actually happens. So, and we saw that ESA actually advertises you can buy a sounding rocket and you can have 13 minutes of weightlessness on the sounding rocket that apparently goes straight up and straight down. And so we also looked at the drop tower experiments where we can see that they can get 13 seconds of weightlessness on a container that goes both up, that gets us weightlessness on both up and down. And we also mentioned some other interesting aspects like NASA, they emulate weightlessness in swimming pools. So, exactly what's going on there. So the speaker is saying that when you go above the Kármán line, that basically that same kind of thing is happening, that there's some substance around you. It's not water, but it has the same effect as to basically remove the effect of gravity. So I think those are all things to think about. The author has a book, The 7 Deadly Misconceptions, on Amazon.com, and it looks like a good read, and it's an inexpensive book, so I don't think you guys have any excuse not to buy his book because it's expensive. Like anyone can afford $2.99, I think. And but then we got into a discussion of exactly what the ether is made of. I don't think the author has any particular embodiment, and we discussed various particular embodiments of what the ether could be made out of, and also things like what's antimatter. And finally, our discussion was about what is matter, and certainly the points of the other people here in the conversation was that that matter is a kind of wave, and that we're some kind of tsunami walking around. And that, of course, I expressed my opinion that I completely disagree with that. That no way are we tsunami. So, but I think maybe that will be a discussion for next week, and that will conclude this week. So I thank everybody who has participated in the discussion, and I would encourage other people to participate more in the discussion. I mean, it's kind of nice to sit and kind of listen in, but this is a science chat, and so I want people interacting rather than it just being kind of a conversation between me and the speaker, or between just like 2 or 3 people. So that will do it for this week's, and hope to see you same time, same place.
Can you just read out a small quote by Einstein?
Yes, go ahead.
Yeah. How does it come about that alongside the idea of ponderable matter, which is derived by abstraction from everyday life, the physicists set the idea of the existence of another kind of matter, the ether. So even he thinks ether is a different kind of matter compared to the protons, neutrons, and electrons. Ether is a different kind of matter. So two things make up matter. Matter is not singular. That is, I just wanted to tell that.
All right, so we've ended up with Einstein. All right, so we will do this again, same time, same place. And actually, if you guys haven't been noticing, I've been using now exactly the same fuse link. So I'm not actually changing the fuse link anymore. So if you somehow don't get the mail message, you can probably just go back to the same fuse link as we used this week, and it should work.
Franklin, was last week's recorded?
It was recorded.
Okay.
If they, these are reposted by David DeHilster, and he just does that when he has time. But if you send me an email, I can send you a direct link from Fuse of the replay.
Okay, thank you.
All right. So if any of you guys are interested in a direct replay Fuse link, if it hasn't been put up on YouTube, just email me. franklinwho.com, and I will send you a direct replay link. The direct replay link does exist for all these conferences.
Because I had a terrible time trying to get in last week. That's why I was asking. I couldn't get connected at all. All right. Thanks, Franklin.
All right. So that will do it for this week's conference.